let's talk arithmetics. By the way, I still have no clue what we're going to do.
Did you get my stick?
No. So, we'll figure it out, though. It'll all work out in the end. So, today we're going to talk arithmetic sequences. In sequences, there are two distinct types. There's arithmetic and geometric. And within those, there's finite and infinite. Okay? So, let's talk arithmetic today. A tall brick building has a decoration that is shown. If each row is 1 foot tall, how many bricks would be in the bottom row if the wall was 15 feet tall? And how many bricks would it take to build that design on the wall? Okay. So there's that. We can see that this is a typical problem for this chapter. Okay, or for this section, I should say. In a few days, we're going to knock that out of the park. Actually, we'll be able to knock that out of the park probably by the end of the day today. Okay? But my plan is today's Thursday, no formative tomorrow. Friday is that's no formative. Monday, we'll have that. Tuesday, Wednesday, nothing. So next week, Thursday, we'll answer that question for sure. Okay? All right. So let's talk what an arithmetic sequence is. An arithmetic sequence is a sequence that has a constant difference between two consecutive terms. Okay? So we're always what? Adding. This is the one that goes with adding. Okay? First one, is it arithmetic? Why, yes. So you're adding 4 every time. Okay, do we all agree? Adding 4 in between each and every one. Yes, so that would be arithmetic. Okay? What about the second one? Yes or no? Why yes, Con?
Because you're adding by -5.
So subtracting is really just adding the negative? Yeah, exactly. Okay? So that one is also arithmetic. Okay? Because we're that different. It's not so much you're always adding something, it's just that that gap is the same size every single time. Okay? So both of those be arithmetic. Okay? Determine if those are in fact arithmetic or not. Talk to me about the first one. What? Adding 10 each time? Okay. So that one's a big ol' yes. What about B? Yes? Exactly. That's where I'm at. Plus 3 plus 5. Do I need to go any further? No. That's a big old no. What about this next one? C. What are we doing here? It looks like we are subtracting 9. Then looks like we are, what's that, adding 18? So that's a big old no, right? Okay. Oh, what about this one? Looks like we are subtracting 12, and subtracting 12. I would go with yeah on that one. Okay. So, here is your arithmetic rule. Okay? A sub n, which can be determined as the last term, or frankly, it can be any term, really, is determined by the first term plus the number of terms, or the term number, minus 1 times d, where d is the difference between consecutive terms. Sometimes you might hear it referred to as the common difference. Okay. You happen to have the ability, the opportunity to put things onto a note card for your tests and your quizzes. This would be something that should go on said note card, because unlike in Algebra 2, I will not be putting formulas on the test for you. Okay? This would be, and I would put it under arithmetic, because you'll have a couple of formulas for arithmetic and you'll have some formulas for geometric. I would put this formula in the arithmetic parts of your note card. In years past, what some people have done is on the note card, they've done one side arithmetic and one side geometric. Okay? So, just so you know, because that's really the two that you're going to have to deal with this chapter. Okay? Anybody need more time on this? Okay? So, I just want to see what you guys remember. So I'm going to give you 90 seconds to write 2 arithmetic rules. Okay? Okay? For those expressions. Ready? Steady. Go. Trying to see what you guys remember. I had the timer and we didn't even have the timer. Alright, so the rule that we are going off of is that bad boy. Bad boys, bad boys. What you gonna do? What you gonna do when they come for you? Okay? So, any term, that's what I'm looking for. I'm looking for that any term thing is equal to the first term. What's the first term of my left sequence? 1 plus n. N is going to be the number of terms that we have. I don't know what n is because I want to find it for any term. So n is going to stay n. Minus 1 times d. What is my common difference? 2. I'm adding 2 every time. So my common difference here, plus 2, plus 2, plus 2. So my common difference here is going to be 2. Now, I like that. I would accept that as a rule, but I like it better, okay, if you wrote it like this. Right? Because then that numbers out in front, and we like to have that stuff out in front of our parentheses, right? But I'd like it even more if you wrote it like this. Whoa. How did I get that? I distributed it in that 2, right? Got 2n minus 2, and then I added 1 to that, and I got 2n minus 1, right? So those are the 3 different variations that I would accept as a rule for that one, right? Then it went on to say, let's find the 20th term. So we need to find a sub 20. Well, the easiest one to put it into is that last one. So that's going to be 2 times 20 minus 1. 2 times 20 is 40. 40 minus 1 is 39. So a sub 20 is 39. 100% on the first one? Yeah? Okay. Second one. What's my first term? Shout it out. 6 plus n minus 1 times my common difference. -4. So that's one of them. That's another one. That's my favorite. Okay. Then it asks us again to find a sub 20. That's -80 plus 10. I'm going to go with -70 there. Yeah, buddy? Writing a rule given one term and the difference. Ooh, yeah. Oh, yeah. Okay, so what is this telling me right here? No, it's not a sub 1. Your sixth term is -16. Okay, so if I'm going to use my rule, okay, that's going to tell me then that my sixth term is -16. So if I use a sub n equals my first term plus n minus 1 times d, there are 2 things on there that I have to have. I have to know my first term in order to make my rule. I got to. Somehow I got to find my first term. And I have to know the common difference. And those are the 2 must-haves in there. Well, I can say then here that the sixth term is -16. If the sixth term is -16, I'm going to have the first term plus what's n? Good. 6. My sixth term is -16. That means n is 6. And d is 9. 6 minus 1 is 5. 5 times 9 is 45. I don't know why that was so goofy. That looks just a goofy. Right? Subtract 45 from both sides, and that gives me negative 61 is my first term. If negative 61 is my first term, my common difference being 9, then my rule is going to be a sub n is going to equal negative 61 plus 9 times n minus 1, or 9n minus 70 is my rules. It then went on to ask us for a sub 18, my 18th term. Well, that's going to be 9 times 18 minus 70. 9 times 18 is 260 what? No. 162. Yes, 162 minus 70 is 92. Okay. If we go back here to this one, those two are the must-haves in order to find the rule. Okay? You now try D. So I know that my 12th term is negative 3, which means my number of terms then is 12. And I know my common difference is 7. Excuse me, negative 7. So then this would become negative 3 equals my first term plus, actually let's go minus here, minus 77. Yes? Which makes 74 be my first term. If 74 is my first term, then my rule, I should say, is going to be a sub n equals 74 plus, let's go minus there, minus 7 times n minus 1, or negative 7n plus 81. Eighteenth term, negative 7 times 18 plus 81. 6, carry the 5, negative 126 plus 81 is negative 45. Yes, Okay. So, the last of the types of problems that you will see is writing the rule given two terms. So now you have two terms in the sequence. Okay? So what you have to do is you are going to have to first write a systems of equations using that. So basically what I'm saying there is you're going to have to use that twice. Okay? Once for each term. So if I were to do this on my 8th term being 21, I would say that that is going to be 21 equals my first term plus 8 minus 1 times my common difference. Because I don't know my first term and I don't know the common difference. Correct? Okay. So that is going to simplify down to be 21 equals a sub 1 plus 7d's. Agree? That's using it once. Now, let's use it twice. Now, my 27th term is 97 so I can write that, which gives me 97 is equal to a sub 1 plus 26d. Agreed? I've got two equations now with two variables. How do you want to solve it? What are our choices? What are our choices? Substitution, elimination, graphing, two more. Kramer's rule and matrices. Okay? So that whole last chapter, we have to do this. Okay? Your choice. I know what I did. Look at it. Substitution would be okay, but not the easiest. Why elimination? You just got to multiply one of them by a negative sign, right? Okay? So, let's solve that system using elimination. So if I do that, I'm going to say negative 21 is equal to negative a sub 1 minus 7d. I multiplied this equation by negative 1. 97 equals positive a sub 1 plus 26d. A 76 is going to equal 19d. So d is equal to 4. If d is equal to 4, then 21
is equal to a sub 1 plus 7 times 4. 21 equals a sub 1 plus 28. Negative 7 is equal to my first term. Agree? Which means then that my rule now, which is step 3, my rule then is a sub n is equal to my first term, negative 7, plus, oops, I should put d in there first, plus d, which is 4, times n minus 1. Or, a sub n is 4n minus 11. Okay. Find me the rule. Find me the 25th term. Agree with those two equations for your system. Okay? $54 is equal to 6d. So d is 9. If d is 9, then oops, I know what d is here now. D is 9. Whoa. So 4 is your first term. That then gives you a rule of a sub n is 4 plus 9 times n minus 1, or a sub n is 9n minus 5. Yes? Which then that would mean, what were we looking for? 25th term? 25th term, yes. A sub 25 is going to be 9 times 25 minus 5. 9 times 25 is 225. Minus 5 gives me my 25th term is 220. Yes? Yes. Okay. Let's make that bigger. Come out as big as I wanted it to be.
When's it due? Monday.